This week on Technically Speaking, we're joined by Chad Jones of the Collapsed Wave Function podcast to play into our stereotype as we discuss the new SpaceX Dragon 2 space module. We brainstorm some new forms of data storage, and we even have a way for you guys to win some stuff. All that and more coming up right now.
Guidance is internal.
Hello, computer.
I'm a doctor, not an engineer.
No, you're an engineer.
Liftoff on Apollo 11. Towers clear.
We're a roll program.
60 seconds. 30 seconds.
Forward.
Farewell stages. Eagle Atlantic. One giant leap for mankind.
Hello and welcome to Technically Speaking, your home on the Brachiolope Media Network for all things engineering and technology. My name is Joe Batwinnis, and joining me as usual is my co-host, Jacob Stone.
What's up, everybody?
All right.
Yeah.
Jacob is super excited, as usual, to be recording yet another fine Brachiolope Media production.
Totally. Let's do it.
All right. Helping us record this fine Brachiolope Media production is another member of the Brachiolope Media Network. We are joined today by Chad Jones.
Hi. I couldn't compete with his, excitement, so I'll just go with that. Hi.
It's hard to compete with Jacob's enthusiasm for podcasting.
Yeah.
So, Chad, you are a PhD candidate in physical chemistry at Brigham Young University, but more importantly to us, of course, is you are the host of the Collapsed Wave Function podcast.
That's true. The collapsed wave function is all mine, and the other two people that do it with me. But yeah, all mine.
Awesome. So, for our listeners who have not explored the other shows on the network, maybe you could tell them a bit about your show.
Okay, so it's a chemistry podcast, and don't tune out just yet. So I'm obviously a physical chemist, so I get into podcasting. What I'm going to do is talk about chemistry. What we try to do is invite people that are doing research on to talk to us about their research, but for like an everyman kind of audience. So what usually happens if you hear about what's actually being researched, either somebody is going to say that say something about their research that is way too broad strokes and it's not what they're actually doing. So if you ask someone working in proteins to tell you about their research, they're just going to tell you about proteins in general. Mm-hmm. And we try to get people on that'll all talk specifically about what they are doing.
Right.
And then also we have other episodes that don't have researchers on that we just kind of talk about whatever in chemistry that we want to.
Yeah, you guys have a fun show, and you talk about some cool stuff. You had I like the show where you talked to the guy who made the posters that had like the fruit and then all the ingredients in the fruit.
Yeah. James Kennedy.
Yeah.
Yes, exactly. So he's a high school teacher that made these little infographics that said, the ingredients of an all-natural blueberry. And he went through and did some very detailed research into what chemicals are really found in a blueberry, and listed them all out as if it was on a food product. And, using very scientific sounding names, basically with the idea to show people that chemicals are everywhere, right, and you don't need to. Yeah, so this idea of all natural, it doesn't mean means there's no chemicals. That's
right. Yeah. Tell that to Chobani.
Yeah, no. We recently did a Chobani podcast. I don't know if you guys.
I saw it in my queue. It's in my queue to listen to.
So we talked about the whole Chobani mess, which if you don't know what I'm talking about, I'm not going to tell you. You have to go listen to my podcast. Anyways, but we talked to a food scientist to tell us about the science behind yogurt and cheese and other dairy, and how what the work that a real food scientist really does. And I like that episode, so you guys should go check it out. It's really cool.
Definitely will.
Cool. Yeah, I really liked I like the idea of showing all of the chemicals that are inside natural products like that, because my high school chemistry teacher, he had this marquee or banner. above his classroom that was like the entire length of the wall, and it just said, "Chemistry is ubiquitous." And
Oh, that's why you use that word all the time. You stared
it
at
is.
it
Like,
every day of the year.
I did for 2 years. I had chemistry for 2 years with him, and it was like the very first assignment that we had, first year chemistry, was to go home and ask our parents what is a chemical. And I didn't know. I at that time I was in 10th grade, I think, and I was probably of the popular opinion that like chemicals are something that's artificial, that's added to other stuff. But my mom was a nurse, and she, I guess, knew well enough that when I came home and asked what a chemical was, and she's like, "Well, everything's a chemical." And I was like, "Really?" And I wrote it down, not thinking that she was correct. And then we get to class the next day, and he's like, "Yeah, everything's a chemical. Like, literally everything. If it's matter, it's a chemical."
Yeah, so I don't know if you. I did a podcast where I didn't have any of my co-hosts with me, so I interviewed my kids, and one of the questions I asked them was, what are chemicals? And of course, they have a chemist that's a dad, so they had that answer ready. But anyways, it was, so you bring up ubiquitous, and I'll just bring this out. I'll point this chemistry fact out. The most studied protein. Do you know what the name of that protein is? It is ubiquitin. Because it's I don't know if it's because we study it so much that it's called that, but basically, like, in my field, when we study proteins, if someone's going to take their first shot at testing what happens to a protein, they're probably going to do it with ubiquitin first. So it's kind of funny that it's like the protein that's all over the literature is called ubiquitin.
Interesting.
That's funny.
There you go, Jacob. Your favorite word has a corresponding protein.
Yeah. It makes me want to figure out the chicken and egg problem, though, on it, is like which came first.
Right.
Yeah, I don't know. I actually don't know the answer to that.
Yeah. But it's not crazy to say that there's certainly plenty of exciting topics to talk about in chemistry. I mean, a lot of the stuff that we talk about from an engineering standpoint has to do with material science, finding out new materials to use in products. And all of that starts with chemistry research. All of that starts with trying to make a new material from a molecular level, and that's like your speciality, right?
Right. I mean, it's not my particular research speciality, but I mean, yes, it is, deeply tied to physical chemistry and things like that. So
yeah, I mean, that's engineering is essentially applied science, right? So it goes back to the joke of being applied science, sort of, for this show.
Yeah, I'm glad you admit that engineering is not science.
It's applied science.
Whoa, hold up.
It's science.
Hold up.
It's applied science.
Hold on.
We want to get into this?
The design life cycle is very, very much parallels the scientific process, okay? You have conceptual design, preliminary design, and then, you go through all the stages, go into sustainment, but you're always looking back and starting at the beginning. There's actually product life cycles that are mostly used in software. They're called spiral life cycles, where you actually continuously update the product. I mean, it's like every piece of software out there, version 2, version 3, version 4. And it's all about collecting results and making new hypotheses and testing those new hypotheses. And it goes very parallel with the scientific method. So I would take issue with that being said that it's not science. Applied science, yeah, totally. Because we're taking the results of prior science and then putting it into action. But at the same time, we're still experimenting. We're still kind of making our own hypotheses about how a design will work and then testing it out. I mean, every product that we develop, obviously the aviation industry, we got to test, Prototypes are developed decades before the actual real product is developed. So, sorry I ranted.
No, I'm just laughing.
You have offended my sensibilities, sir.
I'm just laughing through this whole thing because
I will challenge you to a love slapping duel.
I'm just laughing through this whole thing because what I really wanted to do was come on an engineering podcast and make fun of engineers, and so now I've fulfilled my desire for that.
Get the hits in while you can, Mr. Soon to be an engineer.
Yeah, that's true. I'm going to be an engineer, but, a title is not a mindset. Oh!
This guy. Where did you find this guy?
I don't know. Where did Brian find this guy?
Gosh.
Who let him into the network?
Jeez.
I let myself into the network. Don't you? I mean, you know that, right? I mean, I basically just I just said, hey, you guys should have me in the network, and we're going to be in the network. And then you guys were like, all right. And then I was like, hey, Ryan, I'm going to come on Science Sort of. And he's like, all right. And I was like, hey, Ben, I'm going to come on Titanium Physicist. And he's like, all right. So,
but we invited you.
There was a lot of stuff that happened in the background.
No. I like to think that it was just me pushing my weight around. Be like, guys, you're gonna let me in because that's what's gonna happen. Deal with it.
Yeah, that's okay. You can think that. Pat head.
I will.
I'll just pat your head right now. Virtually.
I really don't want to see the emails back and forth between everyone before I got on about, I don't know, I don't like him because, anyways, continue.
All right, well, while we're on the topic of joining the network, that's a fairly good segue into the fact that it's our first anniversary as a show. Technically speaking, is now 1 year old. Hooray!
Yeah, and though we've had some slowdowns along the way, Joe and I both moved on to different phases in our careers, which meant that we couldn't maintain the twice a month recording schedule. More like I just moved on to something.
Pretty much
double.
just you. Pretty much just you.
Yeah, it's pretty much just me. But Joe's busier than he likes to admit to. So we apologize for that, but we hope we're still bringing quality enough content that you're willing to come back every month. And it looks like you are. It sounds like you are.
I mean, the stats.
Right.
The stats say they are.
The stats show it, and you got to trust the stats. So
Stats, bro.
that being said, I've recently found a newfound love for marketing.
Yeah?
And I've had some success with that, shall we say, in my home business. So that being said, we were inspired by the early flyer contest that Science Sort of did, like 4 years ago, I think it must have been. So we thought, hey, why don't we have our own flyer contest?
Yeah.
I mean, we've got creative listeners. We've got listeners that are enthusiastic about our show and about our content. So what we would like to do is kind of put a little twist on the flyer contest that Science Sort of pitched 4 years ago. Because we're not the greatest at, graphic design, putting together our own pieces of advertisement.
I can make clip art.
Yeah, that's about it. Like Microsoft Office clip art. I do some wicked PowerPoint.
I mean,
stuff.
I can Photoshop some stuff, but it ends up looking like crap.
Yeah,
and then I see things
so,
that people who know what they're doing do, and it's like, man, I can't do that.
Yeah. So instead of doing what Science Sort of did, where they made a flyer and asked you, the listeners, to put up the flyer at your schools, at your locations, and then send us a picture of the flyer put up somewhere, what we'd like to do is have you design a flyer for us.
Yeah, we're gonna do like a two-part contest, so we'll have to come up with two prizes.
We will have two separate prizes. The first prize is going to be the prize that you're probably going to have to work the hardest for, though. The first prize is going to be a judge prize. So if what we would like to have is for the listeners to design a flyer for us, send it in, submit it in, and Joe and I will, as the dictatorial leaders that we are, decide which one is the best just out of our own judgment. We're not going to put this up for a vote, people.
Sorry.
But the second part of the contest will be more...
The same as Science
fair.
Sort of one, right?
Yeah. It'll be fair. We'll leave it up to the gods. So you guys send, after the flyer's been designed, after we send out the final design of the flyer, we'll send that out to you. You put it up at your school, at your workplace, wherever. Take a photo of it, post it somewhere, and that will give you an entry into the contest, and we'll randomly choose a winner from that.
Yeah, post it on our Facebook page, or tweet it to us, or email it to us. Something like that.
Joe, do you have an idea as to what the prize might be?
We'll have to figure something out.
We'll have to figure something out. It'll be pretty cool, though, because Joe and I have yet to actually design a product, marketing product, like a T-shirt.
Yeah, we should do that, too.
I think that could probably be the prize for the flyer design, right? The very first, technically speaking, T-shirt.
Maybe. Or we'll just we'll have something engineering related or geeky enough.
You got to get them excited, Joe. Oh,
what?
Maybe we could get them. Maybe we could send like an engineering prize then. Maybe send them a rocket. Let's send them a technically speaking rocket, model rocket.
I was thinking something
guys,
along those lines.
You guys, what you need to do is have a brainstorm about what the prize will be. That's what you got to do.
Yeah, that's probably true.
But then it's going to get super awesome and super expensive and super unrealistic really quickly.
Yeah.
And it'll
It'd
have
be
something
really
to do with Elon
meta,
Musk,
too.
So.
Yeah.
It's like, for your prize, you get a life-size sculpture of Elon Musk.
Right.
That
Cardboard.
hangs above your bed, just like
The
mine.
cardboard
That's-
cutout.
Now that's technically speaking.
Yes.
That's
We'll figure something. We'll post it on the Facebook page and Twitter when we figure out what it's going to be. But if you're not artistically inclined and you wanted to help out the show in honor of our first anniversary, you could just tell your friends to listen to our show.
That's true.
We would appreciate that too.
If you tell us that you told your friends, we'll send you a smiley face.
Yes, I will send you an emoticon.
Digital pat on the back.
Yes.
Moving on to what's really important in life, Elon Musk. Right. You know, I've learned that when people have a preconceived notion about you, it's best not to try to, like, dash that preconceived notion or your stereotype. It's best to just dive right in.
Right.
So this show has a stereotype of being Elon Musk fanboys, for, you know, to be polite. We've had worse terms thrown at us. It's not really our fault that this is the only guy that's really in the news for engineering marvels.
Yeah.
But
It does cool
but
stuff.
it's true. It's true. We're fans.
His company's
It's hard
cool
not
stuff.
to be a fan. And just full disclosure, because Chad wasn't sure about this, we do not work for Elon Musk. Neither of us. However much it might appear as though we're marketing for him.
This is not secretly the Elon Musk marketing staff.
Yeah, because if it
Elon-
were, we wouldn't be doing a great job at it.
No, not really.
yeah.
Oh, that's it. The prize can be a ride to space. That'll be the prize for the flyer contest.
Oh my god. So the latest piece of Elon Musk news lately is that SpaceX has recently unveiled their new Dragon space capsule, version 2. This is what's going to sit atop the SpaceX rockets in the future. Right now, the current Dragon module that's being used to deliver supplies to and from the International Space Station was designed with humans in mind. SpaceX had previously said that they were going to pursue a human rating on the Dragon version 1 at some point. And I don't know if they've given up on getting a human rating on the version 1 or if this is, supposed to replace
I think
that.
this is supposed to replace that.
It seems to be that's what they're saying.
I think they wanted to make the Dragon 1 human rated capable from the
Yeah.
get-go in case NASA decided to just turn that project on too right away. But now that they haven't for a few years, they've just decided to go ahead and pursue this Dragon 2 and just upgrade it a bit.
Yeah. And I think in any case, it definitely is a next generation space capsule.
Yep.
Spacecraft.
It's a capsule. I mean, capsule's still the right term for it.
Is it? Okay.
Yeah.
I wasn't sure.
Yeah, I mean,
But
it describes
uses-
that blunt body object that uses aero braking to come through the atmosphere. It's a capsule, as opposed to like
Yeah.
a space plane, like the shuttle.
Right.
was.
It's not like the space shuttle where it's gliding back to Earth.
Right.
So and that was one of the interesting topics about it is that it is a space capsule, but it's not going to use a parachute for its recovery. It's going to use thrusters.
Right. But it will have a backup parachute.
Right.
But yeah, it's got upgraded motors of the maneuvering motors that it uses in orbit for its recovery. So it'll come in through the atmosphere, use aero braking to slow down most of the way. Aero braking meaning essentially the drag that generates all the heat on reentry. And then once it pops out of that phase of reentry, it will use rocket thrusters around the outside of the capsule to decelerate the vehicle and guide its reentry course to a predetermined point for an easy recovery.
Yeah.
As opposed to now where the Soyuz capsules come in generally in the area where they want to recover it, then pop chutes, and then it's kind of at the mercy of the wind at that point as to where exactly it lands.
So, I mean, the question I have through all of this is it seems to me if you're going to have one be your primary and one be your backup, I would rather have the parachute as the primary and have the fuel as the backup. I don't know, just because I can see so many more problems that can come with fuel lines and ignition and then things like that. And then just the cost of fuel.
Yeah,
compared to the cost of just using a parachute.
Yeah.
Certainly there are added costs, not only in just having the fuel, but in like the, what's the word I'm looking for? The opportunity cost of not being able to use that mass for payload.
Yeah.
Yeah. And we've talked about this before, and we actually got some really good listener feedback the last time we talked about this, because it was the first time that that SpaceX had the story about their Grasshopper prototype, where they were testing the return capability of their thrusters. So right now, all of the SpaceX rockets that are going to be going up, they all have this added capability to them where they can do a controlled reentry or controlled return.
Yeah, of the first stage.
The first stage, sorry, yeah. So it keeps enough fuel on board so that when it's coming back to Earth, that it can slow itself and keep itself upright. And it's got landing legs on it. Mm-hmm. And the first time Joe and I looked at that, from everything that we had learned in school about the math of just, the extra fuel you have to carry when you carry extra fuel, It didn't make sense. It just doesn't seem to make sense. But we got a really good piece of listener feedback from, I don't remember who it was actually, but they said that it was kind of egotistical of us to say that without actually looking into some of the improvements that were made to allow that advance to happen. And it turns out that not just are they using much more fuel efficient engines so that they can make this happen a little bit easier, but they're also using computers in a way that's allowing them to preserve fuel during the descent phase. So they're kind of keeping themselves stable with the least amount of fuel possible, and then they're slowing themselves at the bottom of the descent as quickly as possible. And
that seems like it would be really like a little frightening.
Yeah.
Just like if I'm imagining myself in the capsule, making that descent, and if it's computer programmed to brake the most efficiently, which you're going to want to brake closest, right? You're not wasting a bunch of fuel braking high in the atmosphere and just going to get up to the same velocity soon. But like your instincts as a human being are going to be to like slow down a lot earlier than the computer will, right? So you put a lot of trust into that.
And there would probably be a different flight profile for the Dragon capsule than the first stage returns. First stage returns aren't going to have a payload at all on board, so they're only limited by the structural integrity of the structure. So they can afford to wait longer. Whereas you're right, if humans are on board and you want to have safety redundancy in there, you're going to have to start slowing earlier just to make sure that your thrusters work. You know what I mean?
Yeah. And these thrusters are dual redundant too. It's it has a bunch of pairs of thrusters all around the outside of the capsule. So if one thruster dies, the other one can take over. I guess they basically run at 50% nominally, and then if one of them dies, the other one can take up the slack and run at 100%.
That's cool.
Okay.
To take over and still maintain thruster control. But I think what I would want to do is essentially, I think the way it was described in the presentation that they gave was they would re-enter, they would do an initial burn to do a system check to make sure all the thrusters are online, and if it passes that, it would continue to a controlled landing using thrusters. If it doesn't pass that, it can pop chutes. But I think what I would want to do is start your controlled landing at an altitude high enough to still deploy the recovery parachute if on your second restart you had a failure or too many failures, right? Although that's probably unlikely at that point.
Yeah, it's hard to say without, being part of the design team exactly how that if statement works.
Yeah. But I mean, that's one of the things that the design team is going to be going through is looking at all the possible failure modes. Like, what if this goes wrong this time? And what if this goes wrong at this time? And just going down and making a giant list of all the possible failures and what to do in the event of that. And it'll certainly be different, like you guys were saying, for a manned capsule versus an unmanned primary stage.
You mentioned all the possible failures, and accounting for all the possible failures. What I thought was really cool about this is that it had a touch screen control. and it looks really, really awesome. I mean, like the touchscreen control looks cooler than anything I ever saw in Star Trek for sure. I mean, it just it looks awesome.
If you haven't seen the pictures of the inside of this capsule, definitely go. Yeah. We'll post the video of the unveiling in the show notes. Definitely go watch it because it's awesome.
And we'll talk some of that structure here in a minute too.
Yeah, so I'm just looking at it and I want to get in and start touching the screen, but then they also have, for like the critical things, that buttons that need to be pushed have a backup toggle switch that can still be used, which kind of made me think, you never see that in Star Trek or anything like that. It's all touch screens, but sometimes touch screens are not what you want, because there are different times when touchscreen is the worst thing you could have. It fails easier, and but I just think it's cool.
Yeah.
Yeah, and one problem with a touchscreen is there's no tactile feedback, or good tactile feedback. So like that's why, that's one thing. Like if you look at the pictures, you have the big giant displays for most of it, but there's still a big giant fire button over on next to the screen, right? That you can mash with your hand and feel it get mashed.
Yeah, and that's like why I like my phone right now, because it does have some tactile feedback it gives. If I press and hold it because I want to copy something, it kind of vibrates right at my finger when it does that. And I think that's a cool little feature that maybe, if before touch screens were really used, people probably didn't think about it, but it is good to know your computer is responding back to you like you expect.
Yeah. And I think at this point we're into like the 4th and 5th generation of glass cockpits in aircraft. And for those who aren't pilots, glass cockpit just means an LCD display instead of a traditional dial and gauge.
Right.
And most military aircraft don't use touchscreens still. And most civilian aircraft don't either. But what they do is they have a grid of buttons around the screen. And so you'll have your display, but then the function for each of those buttons, sometimes they're labeled like F1 through 20. There's 5 buttons on each side. And you'll see the function label change depending on what screen you're on. So that allows you to get the combination of having a screen that can change displays while still having the tactile feedback and the precision is not the right word, but the assurance that you're pressing the right thing. You know what I mean?
Yeah, and there's actually specs for that, right? If you're designing a cockpit for an aircraft, you have to, not only do you have to have tactile feedback, but you have to be able to detect it with a gloved finger.
Yeah.
And so it's not even just you have to be able to push it and feel it push. You have to be able to push it and feel it push with a gloved finger, which means it has to have enough responsive or enough pushback.
Yeah. Now here's what I expect though out of this is that I think that's probably like, the nice, that's the version that they show Hollywood, right? But I wouldn't think that it would be crazy for them to incorporate some of the kind of stuff that they're using on the F-22, where the helmet that the pilot is wearing in the F-22 incorporates eye tracking, and the joystick, the pilot's stick, has buttons that correspond to like essentially mouse clicks based on where his eyes are looking. So he's able to control actual parts of the aircraft with just where his eyes are looking.
That's awesome.
Right. A lot of times with fighters, with a fighter aircraft, you want anything vital to be on the controls so that you can keep your hands on the throttle and on the stick at all times. Mm-hmm. So anything vital that you have to do, you can be controlled via the stick, and then secondary things you can reach for.
Yeah. And we talked about last week the monocle that the Apache pilots wear. Still freaks me out. It's like in the F-22 pilots, they have a heads-up display that's built into their helmet. The Apache pilots just have one eyeball that has a small LCD display above it, and it's semi-transparent, but it overlays flight information just on that one eyeball. And what the Apache pilots learned to do is to actually move their eyeballs independently, so that they could have one eyeball looking left at a target or scanning the horizons, and the other eyeball actually looking at the upper right-hand corner of their display in the monocle. It's freaking crazy. But anyway, I wouldn't be surprised if the Dragon incorporated some sort of special controls like that.
So I can move a single eye, but I can't focus. So like, I mean, I can move one eye independently, but I lose all focus in that eye while I'm doing it. So it's what's more impressive to me is not that they can move independently, but they can focus independently.
Have situational awareness.
Yeah, that's what's really incredible. Is because when I do it, I move just one of my eyes. Basically, my brain just says, no, I can't process both of these, so one of them must be wrong. So it just it basically I get nothing from that eye if I'm doing that. But anyways.
Yeah. All right. Before we totally leave this topic, there are two things that I wanted to talk about because they're chemistry related. So the first is the upgraded heat shields. So one of the reasons why the space shuttle was so expensive to use is that reusable was it's kind of a nice little ha-ha joke almost on the space shuttle because it required so much refurbishment after every single flight that it actually cost more per flight than the non-reusable rockets that Russia was building. And the biggest reason for that was the heat shield. Almost after every single flight, the heat shield had to be completely removed and put back on. And what SpaceX and also NASA, I mean, NASA essentially developed this new material that they're using for the heat shield. What they've got now at their disposal is a heat shield that is truly reusable, that should not require removing and polishing and purifying after every single flight. So hopefully we could.
It's not 100. It's not forever reusable.
No.
It will still eventually need replacement. But yeah, I think they said like 10 or 12 flights before it needs replaced.
Yeah.
Don't quote me on that, but I think that's what I remember from the presentation.
It should be pretty cost effective though compared to the other stuff. And it was designed in the 1990s, and so at that time the space shuttle had already been flying for a little while, so they couldn't really incorporate that into the design of the space shuttle. But certain satellites and other space probes have used it since then successfully. So it should be interesting to see it used on a human-rated capsule. The other thing that I wanted to talk about is in the photos, you can see the walls of the capsule are like a really interesting stainless steel metal pattern. Did you see that, Joe?
Yeah.
So does that to me, I mean, it looks like a monolithic machining, right?
Maybe. They're using a lot of 3D printed stuff too.
Yeah.
Well, one thing that was interesting was that the thrusters are, I think, 100% 3D printed.
Yeah.
So it could be big machining, but it might not be either. They may be trying to go for something else.
Their thrusters are 100% 3D printed. I didn't see that.
It's in the video.
Okay.
It's in the presentation.
That's
they've
awesome.
been working a lot with 3D printed metallics, and so they've got these 3D printed thrusters. They're pretty sweet.
Wow.
Well, think about that, Joe. A year ago when we started this podcast, the latest, public information on metallic 3D printing was that the grain structure wasn't consistent enough to be used in aerospace applications.
Right.
And,
clearly that's false.
yeah, now we've got it.
Now we've got rocket engines that have been 3D printed.
And we've heard statements like that from other aerospace companies just in the past year. So it's not terribly surprising, but it is pretty cool.
Yeah, and also, I mean, other people are getting into 3D printed metallics. I know the Koenigsegg car company is building 3D printed turbochargers.
Nice.
So that's no small stress condition.
Yeah.
In a turbocharger.
And
but anyway.
NASA developed all sorts of crazy technology for the Constellation program that they didn't get to use. They developed this thing called stir friction welding that is used to it can actually it's just a welding process that can be used for really large sections. So like they would stir friction weld the outer shell of this capsule theoretically, but it's a welding process that can be used to weld steel to aluminum. It actually like can mix metals together as if you were stirring, sand together with dirt. It's pretty cool. So I think just seeing like a modern next generation spacecraft is going to be a big change. NASA just hasn't had the budget to fully develop one,
Right.
I know we've rambled on. So you guys have anything else that you want to talk about on this topic?
I think we covered it. Basically, go watch the video because it's awesome.
Yeah, Chad's got some homework because he needs to go tell us what the chemistry, what's interesting about the chemistry of the new heat shield.
Yeah, I'm definitely not going to be able to speak to that right now. But I haven't done chemistry in a long time. I study, some properties of gas phase properties of a single molecule, and so actual reactions and things like that, and bulk properties. I'm not as up to date on that kind of stuff. I mean, like I study, I can trap about 10,000 molecules and study those things. So that's small scale.
Yeah. 10,000 molecules. How?
Correct.
So that's much smaller than would fit on the tip of a needle.
Yeah, it's tiny. Yeah, they're tiny. Just in a mass spectrometer. It's Fourier transform mass spectrometer. If anyone wants to look it up, that's what I use. But
well, before you come on next time, we're going to need you to do some research on phenolic impregnated carbon ablator.
Of course,
of course. It's the carbon fiber preform that they're using for the heat shield. So
yep, I will do that.
Take a look on that. Figure that out, and get back to us.
Okay.
All right, so I think we're going to head on over to the brainstorm segment next. Yes.
Yes.
Oh, I didn't get to talk about Kerbal Space Program.
Oh yeah, you want to talk about Kerbal Space Program?
That's
Chad,
engineering.
Chad is a Kerbal Space Program enthusiast. I have not actually played it. Have you, Jacob?
No, I haven't. But I'm an advocate for it. I've told a lot of parents about it. But I haven't played it myself.
You guys have to go. It is awesome. I will just take a moment to tell what it is and why it's awesome. If you guys will let me do that, it's engineering.
Please do.
I said I would.
Okay.
So please do.
So
I forgot.
So basically, Kerbal Space Program is you're controlling these little green guys that are called Kerbals, and they're on a different planet from the planet Kerbin. And you're developing their space program. So you can either do it as a sandbox game where like all the rockets are available to you from the start, and you can just build a huge rocket and send it out to space and send it to different planets and things like that. Or you can do the career mode where you have to do science. So you do a small trip, you do a suborbital trip, and you do some science while you're up there, and you get science points.
Science points.
Yeah, basically you either you measure the atmosphere or you measure the gravity or pressure or temperature, and you get science points to buy new rockets and make their little space program blossom. And the thing that I really like about it, there's a lot of mods and things you can add on, so you can know exactly, and you have to plan it in a scientific and mathematical way, or you're not going to do it. Because you have to get to the moon, and you can't just point at the moon and then get there. You have limited number, limited fuel. You have to worry about your staging, so you're not carrying a bunch of dead weight, and it's.
Well, what if I want to recover my first stage?
I suppose there is a docking. You can dock, so you could let a stage go and then come back and refuel it at a different time.
I've seen stuff online of people that made fully reusable spacecraft in Kerbal, where they would do not SpaceX's thing, but what's that other company that Scale Composites, like the White Knight, where it would have a plane that would fly you up to high altitude and then drop a rocket off.
So the thing I'm most proud of doing is I have just now completed my International Space Station. I have the space station that's orbiting Kerbal. Kerbin, I guess, is the name. Kerbal is the sun. But I have, I'm just going to say Earth. It's the Earth. So it's orbiting Earth. And I've just put on some new rockets. I'm actually going to send it to Duna, which is the Mars corollary. So I'm going to have a space station that's going to be orbiting Mars, and then have different landers that can go down and come back up. And
sweet.
Yeah.
I'm going to have to start
playing. It is so much fun because what I really like about it is it is a game, but there's no missions that you have to do. It's just from an engineering standpoint, what is the coolest thing you want to do that you think you can do, and then see if it can be done. And the physics in it are pretty incredible, from what I can tell. And I mean, it works like you would expect to. And anyways, what you should do if you want to play this game, download the game, but then go onto YouTube, and there's a guy named Scott Manley, and he has a bunch of tutorials that really teach you the physics of what's going on because he understands the physics of everything. So it's really cool.
Yeah, I've watched a couple videos, not of his, but of just people playing, and I was really surprised at how it was using. It looks like a kid's game. It's got the Kerbals and they're little, they're cute and everything, and it's definitely like presented in such a way as to make it easy enough so that children can play it. Maybe 8 years old, 9 years old, but the verbiage that it's using, the technical terms that it's using are totally accurate. When you get into space and you're orbiting, it talks about perigee and apogee and your max Q, the maximum aerodynamic braking at what point in your orbit, and the delta V required to get to another orbital.
Exactly. And there,
height.
What's interesting about this game is there's cheats that you can download, and the cheats for the most part, the cheats actually make it harder. It'll be a cheat, for example, there's one called Deadly Reentry that makes it so you have to come at the right angle, or you're either going to skip off the planet or burn up. There's another cheat that you can do that makes it so communications in Kerbal Space Program happen instantaneously no matter where in space you are. Unless you add this mod, then you have to get some triangulated satellites up, and you have to build your own satellite system as part of building your space program, or you won't have control of your probes because you don't have satellites out there to bounce the information off of. So It's really cool.
Awesome. Yeah, I'm gonna have to start playing this, and then I can put it on my resume.
If I don't finish my dissertation, it will be because of Kerbal Space Program.
Awesome. So. Well, you heard it here. Go get yourself and your children Kerbal Space Program.
Yeah.
Yes.
All right.
Thanks,
guys.
Now we're going to go to the brainstorm.
Puff the magic dragon lived by the sea and frolicked in the autumn mist in a land called Honolulu. Little Jackie Paper loved that rascal Puff and brought him strings and sealing wax and other fancy stuff. Oh, Puff the magic dragon lived by the sea and frolicked in the autumn mist in a land called Honolulu. Puff the magic dragon lived by the sea and frolicked in the autumn mist in a land called Honolulu. Together.
All right, are you guys ready?
Let's do it.
Ready for the brainstorm where Joe openly admits he knows nothing about it. Listeners, it's going to be a good one. All right, so this week's brainstorm comes to us from listener Chad Jones.
Hey, that's me.
I have heard him.
Which I think is pretty cool. It's something that I've dabbled in, I guess you could say. And I think it's probably something that anybody who's inquisitive has thought about for a little while, at least one time or another. So the question, as Chad worded it, was, what about new forms of data storage? Where can you most effectively store your ones and zeros, if not in the typical way that hard drives do? So I like this question because I get to talk about what is typical first. And then we can kind of delve into what's not typical. So here in 2014, data storage is ubiquitous. See? It's in everything that we've got. I mean, our cell phones have digital storage on them. Everything that we are dealing with has some form of storage. I mean, even your keyboard has a tiny little memory bank that's used to temporarily store ones and zeros in it. And there are multiple different forms of data storage that we deal with on a regular basis. The hard drive in your computer uses a magnetic storage system on metal disks. The SD card in your cell phone uses flash storage, which is a digital. Actually, I don't know a whole lot about exactly the physics and the chemistry behind how flash storage works, but it's not spinning disks. Let's just say that it's solid state. It's silicone being charged and discharged, from what I understand. And then there's CDs, optical media, Blu-ray discs, where the information is physically encoded on the drive or on the disc, and read with a medium. And then there's all the old school technologies as well. There's the tape storage systems that were used in the past, and I guess some are still used now. Floppy disks, all of that. So there's a lot of different ways that you can store data. And because computers are designed around using ones and zeros, the kind of typical way that we see data storage happen on all of those other mediums is in ones and zeros. So on a CD or a Blu-ray disc, they work essentially the same way. There's a tiny little pit that is embedded in the CD, and you've probably seen this in textbooks before. If you look at a CD under a microscope, you can see a little trough that's been etched out by a laser. And that trough can be long or it can be short. And if it's a long, it's a 1. If it's short, it's a 0. And all of the data is encoded on the CD in that digital format. So digital meaning ones and zeros. DVDs are the same way. Blu-rays are the same way. The only difference is the size of the pits.
Yeah, I was going to say, so why, I mean, I know the answer to this, but like, I was thinking it's a cool idea of why a red light from a DVD player versus a blue light from a Blu-ray. And it's because the wavelength, of course, of blue light is much smaller than the wavelength of red light. Yeah. And the real question is, well, why didn't we start with blue, right? We knew that blue had a smaller wavelength. Why did we not start with that?
I know the answer to that one.
Red laser light is red lasers are much easier and it's inexpensive to do. And
not only that, but blue lasers weren't even around when CDs were invented. We hadn't figured out how to make a blue laser until the 90s.
Now, are you sure we hadn't lased blue light before the 90s? Are you sure about that?
Gallium arsenide was the discovery that allowed blue lasers to happen. We had kind of like violet lasers before then.
Well, violet would be even better than
but
blue.
it wasn't true violet. It was a mixture of colors. So in the 90s there was this.
Aren't they all?
Well, yeah,
no, but you don't always have broadband light. You can have narrowband. I mean, that a laser is narrowband light.
Yeah.
So from what I remember from the Popular Science article when I was young, there was this scientist in Japan that figured out a way to use gallium arsenide in a typical laser setup that was kind of like the first instance where they were able to miniaturize the technology to the point where it could be used in like CD and optical media. So maybe that was the true discovery, is that it wasn't the first time that they'd made a blue laser, but it was the first time that they'd made a blue laser on a scale that could be used for reading optical media. And
that was so okay, but anyways,
so
I think it's cool. Continue on.
Yeah, totally. And I think that we're not necessarily at the end either, because we can certainly use other forms of electromagnetic radiation to get even smaller. But that's a whole nother story. Joe and I don't believe that there's going to be any other physical media after Blu-ray anyway. It's all going to be on the cloud. But knowing how it works is pretty cool. And there's one other thing about DVDs and Blu-rays that I think is pretty cool that you may have seen before, but you may not have realized what's actually going on. Have you guys ever seen a dual-layer DVD or a dual-layer Blu-ray?
I have.
Yeah. So what's actually going on there is that there's multiple layers that are semi-transparent, and the troughs that are etched into the material in the Blu-ray exist on a different plane. So the laser has to be able to focus at very small differences in the z-axis. So on Blu-rays, they can actually, because not just have we gotten a smaller laser to be able to read smaller pits and troughs, we've also gotten better mechanisms that can focus the laser at smaller intervals. So the thickness of the layers in the Blu-ray disc are a lot smaller. So there's actually Blu-ray discs out there now that are kind of like experimental that have 4 and 5 and 6 layers. So you've got a lot more data storage because now you're storing in 3D.
It's pretty sweet.
Yeah. And when you look,
But I mean, there's always going to need to be physical storage somewhere.
Mhm.
So the question is still valid, right?
Yeah.
How can we make it better?
so there's a couple different ideas out there that are kind of like the future of data storage. One of them is holographic storage. Have you guys heard of that?
Nope.
So, so imagine this. This is totally Star Trek, right? You get a glass cube, and
Oh, that's exactly what I thought it was going to be.
yeah. So in this glass cube is an intricate three-dimensional lattice of molecules, and the lattice encodes all of the information for the data that's stored inside the cube. So the way that the crystal structure is kind of contained inside this glass cube determines the data that's encoded in that cube. And because you're storing it on in this three-axis system, the idea is that the volume of data can be higher. So you instead of having just ones and zeros that you can encode, you can now have a 0, a 1, and a 2, because you've got an x-axis, a y-axis, and a z-axis. So you can kind of use that to increase your not just your density, but your bandwidth, I guess. I don't know if that would be the right term or not. But they call it a three-dimensional resolution as opposed to a two-dimensional resolution.
I would have thought they would just be essentially a thick CD, like a billion-layer CD.
And that's kind of what the practical solutions are. I gave that as kind of a theoretical way to envision it. But the practical solutions are truly just CDs that have multiple layers, in not necessarily that much different than the Blu-ray multi-layer that I was talking about, except the difference is that in order to actually get all the information out of the encoding from the disk, you have to look at the z-axis. So it's not just like the z-axis tells you information about the data that's being stored there instead of just being another CD essentially that's on the same disk.
Yeah.
So the kind of the cool idea that comes from chemistry, I think, is there are some chemical ways that you can create ones and zeros, right? All you have to have is a molecule that's either in one state or another state, and then so then you're really getting down to the smallest you can deal with, because you're not going to get smaller than an atom or a molecule unless you're really dealing in some other stuff that you're not likely to get anything smaller than that reasonably in the near future. Then like single atom. Anyways, so like the molecules that I study, they're called cucurbitryls. They're basically like pumpkin-shaped molecules that can store other molecules inside of that molecule. So one of the ideas is you have an empty cage or a full cage. That's your 1 and your 0. Do you have something that's bound to the cage or something that's not? And that's your 1s and your 0s. So the problem with that, I mean, one of the things I was studying is in what scenarios, in what under what mechanism is making something bind inside the cage, and what is making it release it from the cage, and how much energy does it take to release it from the cage. And these particular molecules are really selective, which means they're only going to bind to certain other molecules, and they don't bind to other things. So you could make it, even if it's in a big solution, you could make it empty, or you could make it bound to something else. So it's sort of one of those answers that's when you're doing research, at least at the academic level, when you're doing some basic research, you have like, well, this is a possible application for this, but we're not anywhere near that. We're just studying the basic properties of this molecule. But that's like, I think there's some biological ways too. You can use proteins. This in one state or another, folded or unfolded. That's how our eyes work, right? Our eyes work. They detect photons because you have a photon that comes in and it changes the conformation. It changes the shape of a molecule, which unravels a protein. And when that protein unravels, it sends the information to your brain that it's seen some light. And so protein unraveling is a really good 1 and a 0 that's already used by our body, and it works really well. So I think there's some cool chemistry ideas you can do too for that. And the other good thing about using proteins is it's not necessarily a 1 or a 0. You're not really digital. So I mean, you guys know this, but let me just explain that. The difference between digital and analog is not what most people think it is. People can tend to think that digital means it has to do with a computer, and analog means there's no computer. But digital just means like that it's stepwise. Digital means that it's an on-off thing. So like you think of stairs. Stairs are digital because you aren't halfway up a stair. You're either on step 1 or step 2.
Mm-hmm.
Right.
But like a river is analog because you could be anywhere in that river, and that's the big difference. And so proteins can be sort of analog too, and you can. There's some argument that analog may actually be better because you can store a wider variety of information with that one protein. So depending on where it is, you can have folded, you can have unfolded, and you can have states in between that will still give you even more information other than just a 1 or a 0.
It's interesting that you say that because there have been there's two things that come out of that. One, there have been exploration into using systems other than binary to encode information on disks, so hard disks and CDs. So rather than storing everything in zeros and ones, let's take a CD for instance. So instead of having just a short pit and a long pit, you could have a short red pit, a short yellow pit, a short black pit, a long yellow pit, a long black pit. And so you could there's this system called multi-level recording, which was developed in the 90s, or I think in the late 90s. And it encoded 8 different types of data onto a disk. And so instead of a binary system, it was using an octary system, octal system. So there was no 9 and there was no 10, but there was 0, 1, 2, 3, 4, 5, 6, 7. And the idea there is that you could store more data per 8 bits. There's more you can store larger numbers in 8 digits than you can with digital or than with binary encoding. The problem they ran into is that when it came down to error checking and registering the difference between the different levels. So turns out that the difference between yellow and red is not huge. It's not really easy to determine if there's a large temperature difference or there's a voltage variation. And a lot of binary systems, they use voltage differences to determine binary. So it could be 0 volts or 5 volts. It's really easy to tell the difference between 0 volts and 5 volts, but it's not that easy to tell the difference between 4 volts and 5 volts. So from an error checking standpoint, having these huge, clearly obvious differences is better. But there are certainly things that we can imagine that have more than 2 states, like proteins, like you said.
Well, and actually, the situation you bring up is one of the reasons that proteins would be difficult, because proteins don't just exist in a on or off. It's an equilibrium where they're switching between folded and unfolded, and which part, it's moving all around. It's not a static 1 or a 0. So that there's like plenty of things that would make protein data storage difficult. Mm-hmm. That's just one of them. Yeah.
Well, there has been one example so far that I've been able to find of using biological data storage, and that's DNA data storage. So. Right. And I'm not talking about the data that's stored in yours and mine and yours, our DNA. But I mean, actually, human-created DNA strands that encode information. So in 2013, there was 5 million bits of data appearing as a speck of dust to researchers, consisting of text files and audio files, were successfully stored and then perfectly retrieved and reproduced from a DNA structure. So it included all 154 of Shakespeare's sonnets, a 26-second audio clip by Martin Luther King, and a well-known paper on the structure of DNA by James Watson and Francis Crick.
Because, of course, that you'd have to store that information in DNA.
Yes.
A little bit a little bit recursive. I like it.
Well, the only thing was the per megabyte cost were estimated at $12,400, which is a bit higher than hard drives right now.
Right now.
Yeah.
I mean, you could get that. You could get the DNA storage down. I mean, you just perfect it, and
Yeah. Well,
it's things that can happen.
it's in the very, very early stages, and the data density of it is huge. The potential for this is pretty massive, and not just DNA data storage specifically, but biological data storage. This is kind of the first foray into biological data storage, but it's not crazy to think that there might be some other protein that's more easily manipulated, that's more stable long term, that is, able to be incorporated more easily with electrical components, that is still biological but can be used for data storage. And maybe we just haven't found that yet, but the research that's being done on DNA data storage now can be used to refine that process and make it viable.
Yeah. So one idea that I have for data storage, this is like the idea that will not work, but I like to think of ways that you could store your ones and zeros that would be completely ineffective, but you could do it.
Uh-huh.
So a single one or a single zero is a byte, correct?
A bit.
A bit?
Yeah.
No? Oh, yeah,
A byte is,
okay, yeah.
byte is 8 bits.
That's right. It's right. Okay, a one or zero is a bit. Okay, so imagine you have a parking lot that has a ton of cars in it, and the cars either have their headlights on or off. I think it's an interesting question that I don't have the answer for, and maybe we'll leave it as an exercise for the listener to tell us what area of a parking lot would you need to store all the information in one Technically Speaking podcast? How big would your parking lot have to be?
How many spots? How many spots would the parking lot have to have?
Exactly. How many spots would a parking lot have to have in order to store all the data for this episode of Technically Speaking?
Yep. Our listeners can definitely calculate that, I'm sure. So
yeah,
send in the answers, and we'll figure out a prize to send.
I just think I really like thinking about ideas like that don't make sense and you would never do, but you could, because I can go to my Walmart parking lot here, and you could store data in the Walmart parking lot if, and all the questions you ask about actual data storage come up if I'm doing this example too, because you can say, well, how cost effective is it? Not at all, because you need to buy a lot of cars. What space are you taking up? That's something that you need to think about in all data data storage. And how long will the data stay stored? Well, not very long, because you're probably going to run out of you won't be able to keep your headlights on forever, and so you're going to lose data through that way. I don't know. Maybe it's just because I'm a big nerd, but I like thinking about like ways like that, sort of like this wouldn't work, and we would never do this, but you could. And what would the implications be? Think if you had to store data that way, how different your life would be, right? Like you have your own personal parking lot with a bunch of cars, and you're like, all right, now what was that word I wanted to remember? Yeah.
Chad's going to be the next John Hammond. He keeps thinking about if we could, and doesn't think if we should.
Yeah. So everyone has their own personal parking lot for their USB drive that they can carry around their parking lot.
Right.
Mm-hmm.
Anyways,
well, nope. I can't. I can't say that I would be, a customer of that data storage solution, but it could be done.
But maybe I'm crazy. But I think it brings, by telling somebody, by explaining why that's a bad idea, it lets you see what important things do you need to focus on for actual data storage.
Yes.
You know what I mean?
Mm-hmm.
Yeah, and we as humans would prefer that data is stored in the least ambiguous way possible, right? Like, if I'm trying to get a message across to Joe, then what I'm doing is I'm taking the thoughts from my brain and I'm encoding them into a language that Joe has literally grown and learned to understand. So when I speak to him, that's the fastest possible way for me to transfer that information to him. I could transfer that same information to him a number of different ways. I could type it and send him an instant message. I could write him an email. I could send him a letter, and he interprets that data in different ways. So if we just limit what we're talking about to numbers, we work on a decimal system. We learn math from 1 to 10. And so me sending numbers to Joe, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, is the most convenient, least ambiguous way possible for him to understand them. When we talk about binary systems, those aren't for humans. We didn't really we didn't really grow up on using binary as a way to think about numbers in a manageable sense. And so,
right. Well, also we aren't a series of switches.
Right. So
we don't think in on and off.
So when you think about data storage from that sense, just kind of like the higher abstract level sense, you start to realize that there's lots of ways that you can encode data into things. I can encode the fact that I have a message to send to my secret Russian contact by putting a paper cup upside down on top of the right trash can in Central Park. You know what I mean? Like.
Mm-hmm. Note to self.
Yeah,
Jacob
I was going to say, actually, I have no idea what you mean, but continue on because I haven't.
Well, that's kind of the way, spies during the Cold War would send signals, and that tiny amount of information, this cup being flipped, encoded a much more complex signal.
Right. Well, and that kind of gets back to what I was thinking about when we were talking about the 3D and you were talking about not just zeros and ones, but more than that. Uh-huh. Is it kind of comes down to how you can read the data too. Like computers read data as zeros and ones because they're a series of switches.
Yeah.
Right. And that's how they can interpret data. So if you wanted to get crazier than that, you would have to perhaps rework how computers think and can interpret data. Mm-hmm.
Well, a good example might be the golden disc that's on the Voyager spacecraft.
Mm-hmm.
You guys know about that? Did you watch that episode of Cosmos yet?
I did. Yeah. I knew about it before.
I knew about it before.
Yes.
In fact, I have plenty of knowledge that didn't even come from Cosmos. But continue.
So for the listeners who haven't heard of it yet, go look it up. But there's a disc that's, for all intents and purposes, a record, right? It's the size of an old record that was used in the before CDs, and it's encoded with both analog and digital information on it. That's the interesting part, is that there's audio information that's encoded analog in the same way that that old traditional records had tiny variations in the depth of the groove that the needle was following. And so the audio was encoded in an analog data storage system. It was a constantly varying height of the channel that's in the record. And CDs are not the same, and that's why kind of like music aficionados think that records have better quality and everything, is because they theoretically have a wider range of possible sounds.
And cassette tapes work the same way except magnetically.
Uh-huh.
So, I mean, like when a cassette is recorded, the strength of the magnetic thing that is is making the recording of it is changing. So it's more in an analog way.
Actually, I don't think I even knew that, but I'm
pretty sure that's true.
Yeah. So yeah, I mean that was an analog data storage system, but on this same record, they also had digital data stored. They had some way, and I don't know exactly how they did it, but they had like some universal mathematical formulas, like Pythagorean theorem and the volume of the area of a circle, things that basically would prove to any other intelligent life form in space that saw it that these are like universal mathematical principles that every intelligent species should be able to eventually get to. And so it proves to them that we're a species that uses the same laws of nature as they do. And I thought that was pretty cool because it encoded a much more complex signal. You know, it was a coded message. It's not just what's actually in the disk, it's the implication of what's in the disk. It says to whoever receives it, not only do we want you to receive this, but we want you to receive the message that we want to know about you and we want you to know about us. And from a data storage standpoint, talk about the density of information that's stored in that's a lot of that. Maybe I'm getting philosophical here. There's a lot of.
I was just going to say that.
You're getting mad philosophical right now.
I was going to say.
I mean, that was a Carl
speaking.
Sagan thing. Sorry, say that again.
I said this is now going to be philosophically speaking.
Philosophically
speaking is the new name.
Yeah.
Of the show.
Well,
I think once Jacob starts to get preachy is when it's about time to wrap up the brainstorm.
It is. But if you can't appreciate the golden disc, then it's hard to be a human engineer, you know?
Sure.
One that engineers humans, or like
I mean that goes to my data storage proposal, which is like the Matrix, right? Just start using brains.
Were you the one that was telling me that was supposed to be the original storyline of the Matrix?
Nope.
No. Okay, so somebody told me that originally the way that the script for the Matrix was written was that everyone's brains inside the Matrix were actually storage systems for the Matrix system. It was the hard drives. And
that makes more sense than using them for energy, because that doesn't make any sense at all.
Right. But
I should have stuck with that.
But it wouldn't have made any sense from the standpoint of like allowing them to live out their lives. You know, they wouldn't have this life that they would live out if they were actually storing data, unless it was encoded in some genius system that allows both to happen, which is, I guess, possible. Yeah. But I digress. We've digressed. This show has digressed, but we hope that it was entertaining anyway.
Yeah.
Chad, thank you very much for coming on.
No, thank you guys.
Yeah,
really appreciate it. Next time we'll try to have, some better chemically related stories. But
yeah, I tried looking for them, and then I couldn't really find any.
But you're going to be an engineer soon.
That's true.
Chemistry, so you'll be able to bring the stories to us.
Yeah, and I will. Yeah.
Let's get that on. I guess it is on record now. Chad is going to bring us stories.
Yeah. Okay. Yep. I am now the new whatever.
Chemistry.
You're going to be the chemical engineering story generator.
That's it.
Yes, that's you. That's your title.
Okay.
Yeah.
I'll accept it.
All right. Let's wrap this junk up.
Yeah, let's do it. But anyway, yeah, thanks for coming on, Chad. You're a great guest.
Yeah, thanks.
Appreciate you putting up with my my exhaustion, my exhausted state,
and your philosophical ramblings.
My philosophical ramblings, which are, I think, infinitely entertaining, but maybe not everybody agrees.
Well, that's the problem. Is you think they're infinitely entertaining. So.
Right. And if you don't think that they're infinitely entertaining and you want to write Jacob an email, you can do that by writing an email to techspeakpod@gmail.com. You can also follow us on Twitter @techspeakpod. And you can hit us up on facebook.com/technicallyspeakingpodcast. You can find all that information at www.technicallyspeakingpodcast.com. And if you have other things you'd like to suggest, like perhaps you have a chemical engineering story that we can have Chad back on for, you can drop us a line at any of those places. Or maybe you'd like to submit a flyer for our flyer contest, you can do it at any of those places as well. Or if you have a brainstorming segment that you'd like us to talk about, we'd love to hear from you. So let's plug some shows. So Chad kind of already plugged his show, the Collapse Wave Function podcast, but we have a bunch of other shows on the network. Jacob, you want to tell them about some of them?
Sure. This week's special show that you should be listening to is brought to you by Technically Speaking, but is Science Sort of. I mean, seriously, if you haven't heard Science Sort of at this point, then I don't know why you're listening to our show. It's what started it all. It's the beginning of the Brachiolope media. It's where Brachiolope makes sense. If you don't...
Does Brachiolope make any sense? I had to explain Brachiolope to some friends at a wedding I went to the other day.
Yeah, I mean...
I still need it explained to me, but...
it's So one of the recurring themes, so like Elon Musk is a recurring theme on Technically Speaking, a recurring theme on Science Sort of is cryptozoology, which is the study or conspiracy of creatures that don't actually exist, like the Loch Ness Monster and Jackalope and the Yeti. What was the one that they said is in Santa Cruz? Is it the Yeti or is it Bigfoot? Bigfoot.
Yeah.
So Bigfoot falls under the topic of cryptozoology. And so the show decided that since it was a recurring theme, they decided to make their mascot a cryptozoological dinosaur, since half of the hosts at the time were paleontologists. So they made up the Brachiolope, and it's essentially just a herbivore. I'm going to screw this up horribly because I don't know dinosaurs at all, but some sort of herbivore dinosaur with a deer's rack antlers.
It's a Brachiosaurus, right?
Yeah, Brachiosaurus with antlers.
An antelope.
Mm-hmm.
Yeah.
So it was the mascot of the show long before the podcast network became a thing. Brachiolope is just it's a cool word that nobody else uses for the names of their network.
Were you explaining that to me or to your listeners?
Both.
Okay, because I got worried there that maybe you didn't realize I was being sarcastic when I said I still needed to explain to me.
Nope, I did not realize you were being sarcastic, but that's
I was just
for the listeners' benefit.
I was just saying that it's so ridiculous. Even I needed to explain. Anyways.
Yeah. But science sort of covers all of the range of topics that we're interested in, and they really are kind of the catch-all for the network, but they tend to focus more on the things that Ryan studies and Patrick studies and Charlie studies. So you come to our shows our show for the engineering, Chad's show for the chemistry, Titanium Physicist for the theoretical physics, Weekly Wienersmith for biology and parasitology, and Astrarium podcast for astronomy. Is that all? Did I get all of them there?
Yeah, that's all.
Yep. For now.
Ooh.
All right. And on that note, it's time to end. So we will see you all in about a month. Thanks for listening.
Peace out,
Bye.
homies.
Bye.
Laters.
All right, so we'll be back in a few with the brainstorm.
Get him excited for it, Joe.
I did. I was so exciting. I mean, I can't match Chad's excitement for Kerbal Space Program.
Is it obvious what I'm really excited about? I'm like, yeah. So I have a podcast. It's called The Collapsed Wave Function. Like, but listen to me about Kerbal Space Program. It's awesome.
You guys, you have to play this game.
Listen.
No. Screw the podcast.
Linda, listen.
Kerbal.